Hello grade 9s, this is Mr. Miller and welcome to lesson 8.3 on solving equations in the form a times brackets x plus b equals c. So the first thing we want to do is practice our checking, showing a check for each of the following equations. So we have an equation with what we think might be a solution, we want to check it. So let me just zoom in on one at a time and take a close look. Alright, the first one we have the left-hand side of the equation originally is 3 times x minus 5. If you replace the x with 4, then when you calculate left-hand side's value, it will be negative 3. But the right-hand side of the equation is actually 18. So since the left-hand side is not actually equal to the right-hand side when x is equal to 4, x is equal to 4 is not a valid solution for this equation. So now let's take a look at part B. The original left-hand side of the equation is 0.2 times x plus 3. The solution we think it might be is x equals 11. When we replace x with 11, and we calculate the left-hand side, we get 2.8. But the right-hand side is 1.4. So since the left-hand side is not equal to the right-hand side when x is equal to 11, that means x equals 11 is not a valid solution either. So now taking a look at part C, alright, here's part C. The original left-hand side of the equation is x plus 3 over 5. When we replace the x with a third, then we add 3 plus a third, which gives us 3 1/3. We have to divide by 5, which means dividing by 5 over 1, which means multiplying by the reciprocal, 1/5. And now you can do some simplification. Dividing the 10 by 5 you get 2, dividing the 5 by 5 you get 1. And that means to get the answer here for what is the value of the left-hand side when x is equal to a third, you just have to do 2 times 1 and 3 times 1, and that gives you 2/3. Now we can see that the left-hand side is this time equal to the right-hand side, so therefore we can say that since the left-hand side and right-hand side are equal, that means that x equals 1/3 is a valid solution for this equation. So now let's take a look at number 2. And in number 2 we want to identify the error in each of the following equations that were solved and then write a correct solution. So let's take a close look at 2a. In 2a we have an equation 0.4 times brackets x plus 2.2 equals 5.4. And it looks like this person has decided to expand the brackets first, so doing 0.4 times x, and whoops, they should have done 0.4 times 2.2 as well, because that is the distributive property. So we're just going to indicate that this term should have been 2.2 times 0.4. So the rest is going to be wrong. Let's do a correction starting from that point. It should have been 0.4 plus 0.88, because that's 2.2 times 0.4. And the right-hand side was still fine. Next, we want to take away 0.88 from both sides. And that gives us 0.4x equals 4.52. And now we can divide both sides by 0.4 to get x equals 11.3. Let's take a look at the next one and see if we can figure out what the mistake is. So we've got an equation x plus 3 over 5 equals 4 over 7. Now this person has decided to multiply the left-hand side by 5 and then do nothing with the right-hand side. So this is the problem. The right-hand side should be multiplied by 5 as well to maintain that equality. So we're going to take over at this point and show how that should be done properly. So if you're multiplying the left-hand side by 5, you also have to multiply the right-hand side by 5. And so that means you're doing 5 over 1 times the left-hand side and 5 over 1 times the right-hand side. I write it as 5 over 1 so that you know how to do the multiplication of fractions. The 5's divide out on the left-hand side, and so you're left with just x plus 3. On the right, you have to do 5 times 4 is 20, and 1 times 7 is 7. Now we can subtract 3 from both sides. Now the 3 can be written as 21 over 7. You want to have that common denominator of 7. And that gives you negative 1/7 for your x value. And that's the solution for this equation. Next thing we'd like to do is solve and check for both of these equations. And so let's take a look at the first one. We have 2 times x minus 4 equals 12. In terms of order of operations, what is being done to x here? You're subtracting 4 first, then you're multiplying by 2. So to use the method of inverses, you have to divide both sides by 2 first, which leaves you with x minus 4 equals 6, and then add 4 to both sides, and that gives you x equals 10. To do a check, we start with the original left-hand side and right-hand side of the equation. We replace x with 10. We calculate to make sure that the left-hand side and right-hand side are equal. We can see that they're equal, therefore we know this is a valid solution. Taking a look at part B, we have an equation here, 3 times brackets m plus 0.5, close brackets, equals negative 2.1. And the order of operations, what we're doing to m is we're adding 0.5, then we're multiplying by 3. So to solve, the first thing we should do is divide both sides by 3. That leaves you with m plus 0.5 equals negative 0.7. Now we can subtract 0.5 from both sides to give you m equals negative 1.2, and that's the solution for the equation. Now to check, we start with the original left-hand side and right-hand side. We replace m with negative 1.2. We calculate, and we find that the left-hand side is equal to negative 2.1, just like the right-hand side. So since we know the two sides are equal, we know that m equals, sorry, that was supposed to be an m here, m equals negative 1.2 is a valid solution. Now taking a look at number 4, we want to solve each of the following. So we have an equation 3/4 times x minus 8 equals 7.5. Order of operations here is what you're doing to x, you're subtracting 8, then you're multiplying by 3/4. So the first step is to divide both sides by 3/4. Now that's a little bit of a tricky thing because the 7.5, first of all, you need to change to improper fractions, 15 over 2. And to divide 3/4, you have to multiply by the reciprocal. I mean, the 3/4 divided by 3/4, obviously that's just 1 times x minus 8. So that's gone from the left-hand side. But you've got to do a little bit of work to calculate the right-hand side. In any case, there's a factor of 3 that divides out top and bottom here. You're left with 5 and 1. There's a factor of 2 that divides out with these two, so you're left with 1 and 2. Now you can do 5 times 2 and 1 times 1, and that makes it a lot easier. You've got x minus 8 equals 10. Now just adding 8 to both sides, you get x equals 18, and that's the solution. Now over here in part B, we've got x plus 14 divided by 4 equals 2.5. What are we doing to x? We're adding 14, then dividing by 4. So the first thing we should do is multiply both sides by 4. That's a little bit tricky. I mean, there's a factor of 4 that divides out here, so that's the easy part. But with this, you have to change the 2.5 into improper fractions, 5/2, and the 4 can just be written as 4 over 1. You can see there's a factor of 2 that divides out top and bottom here. 4 divided by 2 is 2, 2 divided by 2 is 1. And so what you're left with is, on the left-hand side, x plus 14, and on the right-hand side, 5 times 2 is 10, and that's it. Now you just have to subtract 14 from both sides, and you get x equals -4 as your solution. Okay, next we want to solve each problem using equations. So the first question, we have two cars leave Calgary at the same time, traveling in opposite directions. Their average speeds differ by 5 kilometers per hour. After 2 hours, they are 210 kilometers apart. We want to find the speed of each car. So first of all, although we don't know the distance traveled by each car initially, we do know that their speeds differ by 5 kilometers per hour. So what I like to do is I set up this chart of distance, rate, and time. Rate is just another word for the speed. And I can set up that car number 1 has a certain speed x, and I know that car number 2 is going to have a speed maybe 5 kilometers per hour faster. You could put x minus 5 if you want to have it 5 kilometers per hour slower, but most people like to work with positives. Now, they're both traveling for 2 hours. So that means that the distance that they travel, and I guess you need to know that distance is speed times time. You multiply these two things, 2 times x, and that's 2x. You also do 2 times x plus 5, and, well, you can just leave it like that, 2 times x plus 5. We know that the total distance between them, the distance that's traveled by car number 1 and the distance traveled by car number 2, since they're in opposite directions, add those together and it should add up to a total of 210 kilometers. So we're actually just going to use this column here to make our equation. So notice that the first step is you set up this chart and you fill in this chart. It really wasn't necessary to use these last two boxes here. But now we've made an equation. The next thing we need to do is solve the equation. So we can't use the method of inverses yet because we've got multiple x's in this, or x's in multiple places in this equation. So we need to do a little bit of algebraic manipulation before we go any further. So we're going to use the distributive property doing 2 times x and 2 times 5, and that'll give you 2x plus 10. Next we can collect like terms. The 2x plus 2x is 4x. Now we can move the 10 to the other side, so subtracting 10 from both sides, we get 4x equals 200. Now dividing both sides by 4, you get x equals 50. Or as cool kids say, 50. So now we want to answer the question, we want to find the speed of each car. So one car has a speed of 50 kilometers per hour, that's car number 1. And car number 2 is 5 kilometers per hour faster than that, so you have to do 50 plus 5, that's 55 kilometers per hour. And last word problem we're looking at here, we've got a number plus 1/3 of itself plus 1/8 of itself is equal to 70. We want to know what is the number. So first of all, we're going to let n represent that number. We know that the number plus 1/3 of the number plus 1/8 of the number is equal to 70. So this is translating that sentence into algebra. Now, in order to solve this equation, it's a little bit tricky dealing with fractions, so maybe what you want to do is multiply both sides by a least common multiple. So let's take a look at how you do that. Multiples of 3 would go 3, 6, 9, 12, 15, 18, 21, 24, 27, and so on. Multiples of 8 would go 8, 16, 24, 32, and so on. You can see that the least common multiple of 3 and 8 is 24. So now we're going to multiply both sides of the equation by 24. And so what you need to do is 24 times n. You also need to do 24 times 1/3 n and 24 times 1/8 n. So that's the distributive property, multiplying it by all three of those terms. Now the 24 you can write as 24 over 1. You can see that there's a factor of 3 that divides out top and bottom here. You're just left with an 8. Multiplying the 24 over 1 by 1/8, you can see that there's a factor of 8 that will divide out here. You're left with 3 and 1. So that makes multiplication a lot easier. We've got our 24n, we've got 8 times 1 and 1 times 1, so that's 8n. We've got 3 times 1, 1 times 1, so we've got 3n here. Now collecting like terms, 24 plus 8 is 32 plus 3 is 35n. And now dividing both sides by 35, you get the solution n equals 48. So to answer the question, the number is 48. That concludes this lesson. If you have any questions about how I did things here, please don't hesitate to ask in class, and we'll see you there.